2021, Energy Safe Victoria took the perspective of upgrading our auditing program, and we've moved away from a quantitative approach to a more qualitative approach. This is a screenshot of one of our dashboards that we can use real-time tracking of our auditors out in the field to get a sense of what defects and what quantities of defects that the auditors are finding. So in 2021, when we revamped the program, we discovered a benchmark of 60% compliance, only 60% compliance, which means 40% of the installations that we were attending had at least one defect in there, which wasn't a great reflection on the industry as a whole. From that, we looked at what the defects were. And this is another screenshot from the dashboard that shows us a quantity of defects in specific fields, switchboards and testing. As you can see, the larger the diagram, the larger square in the diagram, the larger the quantity of defects we were finding. So we worked with industry and developed some educational pieces and some frequently asked questions, and we use those documents and that information to help guide industry on where we're seeing the defects occurring. And we continued that through 2022 into 2023, and we started to see the defects rate decreasing dramatically. So by the end of 2022 into 2023, we saw compliance rates up to 70 and 75%. Into 23, 24, 75% up to around 80%. And we're currently hovering at around 85% compliance, as you can sort of see here, as illustrated on the dashboard, which is a great demonstration of when Energy Safe Victoria works with the industry to guide them on compliance matters, that the industry will react, and it's refreshing to sort of see those compliance rates at hovering around that 85%. However, there's still a number of defects in the system that we still continue to see, and today I'm just going to speak around, on a few of those ones that we see at the top of the list. One of the most common defects we still see today is cable entries entering into switchboards. The wiring rules require that cables that enter into switchboards enter through close-fitting holes. And it goes on to say the close-fitting hole is a gap of no more than 5 millimeters. As you can see from these diagrams, that these holes or the gaps around these cables are well in excess of the 5 millimeter requirement. Ways that you can ensure that your cables enter into switchboards through close-fitting holes is using a number of methods, laying up the cables in a way that reduces any gaps between the conductors and cables. Enclosures, the entry holes are made to the right size, so the cables will fill up the holes. Correctly sized cable glands, and also using correct internal seals provided by switchboard manufacturers. And one of the most easiest ways to address the close-fitting holes is using a fire-rated sealants, and there's a number of those on the market that are available. The importance of having close-fitting holes is that a fire that starts in a switchboard can propagate outside the switchboard and typically chimney up through the top of the switchboard into a building or other structure, and allowing that fire to propagate throughout a building. So it's quite important that we have these close-fitting holes around cable entries. Another defect that we see quite a lot of is failing to comply with manufacturers' installation instructions. In 2018, the wiring rules put the new wiring rules put a large emphasis on complying with manufacturers' installation instructions. This is just one example of one of the defects was identified. So as you can see on the diagram on the manufacturer's installation instructions, it clearly states that smoke detectors or smoke alarms should not be installed within the 300 mil space in the corner of walls. As you can see by the photo of the actual installation, that smoke alarm is definitely within the restricted or prohibited space there that the manufacturer provides. why there's such an emphasis on manufacturers' installation instructions is because the manufacturers know their products better than anyone, and they provide their instructions so the equipment will be installed to operate correctly and operate safely, taking into a lot of factors such as external environments, location, and even upstream protection and termination of cables or appropriate cables to supply that equipment. So again, it's very important to comply with manufacturers' installation instructions. Another common defect is earthing of electrical equipment. And here's just a couple of examples of equipment not earthed or where earthing hasn't been made correctly. However, this comes in lots of different arrangements. It can be from poorly secured lugs on the ends of cables, ineffective conductor size, excessive lengths of conductors as well, limiting or impeding fault loop impedance requirements. Again, the earthing of electrical equipment is extremely important to ensure that that upstream protection operates correctly and that any touch voltage on electrical equipment is kept to a minimum. Labelling of switchboards. The wire rule says that the switchboard should be labelled so that the operation of equipment can identify what part of the electrical installation the individual circuit breaker or switch controls. I'll set aside the power and light for a moment. I just wanted to focus on the 6 air conditioners installed. It's important that equipment is labelled correctly or the circuit breakers are labelled correctly because particularly with air conditioners, that can be equipment that is worked on by non-electricians, so they don't clearly have a way to test that electrical equipment may be isolated, and it may be just for mechanical maintenance, such as replacing a fan blade. A more appropriate way to label a switchboard might be to actually use labels that clearly describe the part of the electrical installation that switch controls. Particularly with the air conditioning here, we've got upstairs air conditioning, downstairs air conditioning to indicate which air conditioning that operates. Also with light and power, and Energy Safe Victoria isn't going to start issuing defects for this. However, it'd be great to see that as we move forward in the future that we use power and light labels as well and add to them the actual parts of the installation that those power and light circuits are supplying. Another common defect that is issued is insufficient information on certificates of electrical safety. The legislation says that information on or the description of work on a certificate of electrical safety needs to be complete, accurate, and legible. If you're using electronic certificates of electrical safety, legibility is probably not too much of a concern, but the information needs to be complete and accurate. This is for a number of reasons. These certificates are used by different individuals throughout the certificate's life. It could be the owner, the electrical inspector, building surveyor, and also Energy Safe Victoria and our auditors. So a description that is as short as to upgrade an existing main switchboard doesn't give a clear description of what work was actually carried out. Did that include consumers' mains? Did that include main earthing system? And it might be taken from an auditor or a building surveyor that they were or weren't included as part of the work. So it's sometimes also important to include on a certificate of electrical safety what work wasn't carried out. So this might include a better description might read something to the effect of upgrade the switchboard, replacing main switch and whatever quantity of circuit breakers to the existing consumers' mains and existing earthing systems. So more information and a clear description, a clear and complete description of works is very important on a certificate of electrical safety. Lastly, I'll just talk about this as another common defect we see where cables aren't correctly terminated in things like circuit breakers and neutral and earth bars. The wire rules say that circuit cables, particularly copper, stranded and flex conductors, need to ensure that the Strands don't come out of the terminal. And there's often a lot of discussion around should this be done using ferrules or bootlaces. The wiring rules don't specifically ask for those to be used when terminating, but they do talk about strands not escaping the terminal. So as we can see in this diagram over here, we've got strands that are sticking out or have escaped the terminals. In this, the whole set of conductors in the bottom of the, possibly the main switch have come away. And here a conductor, one of the strands hasn't even entered into the terminal in the first place. So it's quite important that we terminate correctly. A number of reasons. Stray strands can cause short circuits. They can reduce the current carrying capacity of the cable or allow terminals to loosen over time. So again, quite important to ensure that we terminate correctly. And going back to manufacturers' installation instructions, a lot of our manufacturers' installation instructions, for example, will tell you certain stripping lengths of conductors to go into the terminals as well. Lastly, I'd just like to discuss some additional powers that Energy Safe was recently given with some amendments to the Electricity Safety Act. These include the ability to immediately suspend electricians and REC's licenses and registrations. Previously, to take action against an electrician that we had concerns about carrying out unsafe work or fraudulent work, for example, we have to go through quite a long and extensive disciplinary action process, which could take a number of months. That means that an electrician could still be working in the industry or an REC operating in the industry for carrying out unsafe or non-compliant electrical work. It's not an action that we would take lightly, and we would do it with a lot of due care and consideration, but it is an ability now that Energy Safe has to suspend immediately registrations and licenses. We also have the ability to issue increased penalties, particularly around unsafe electrical work. This came about due to increased instances of non-electricians carrying out work. For example, we've seen a spate of homemade battery systems incorporating solar systems, often seen around people carrying out things like bit mining or running small commercial operations. And we haven't had much of a deterrent in the past to prevent people doing that. So we hope that the increased penalties will send a message that this is taken very seriously. Also, Energy Safe Victoria can now apply for injunctions. And an injunction is where Energy Safe will apply to the court, and the court will make orders to prevent a person continuing on with a certain activity or certain undertaking. In the past, we've had instances where Energy Safe has attended unsafe sites where, again, often batteries or solar systems are installed, and will direct the owners of those systems to disconnect them from power supplies and the like. And no sooner we're out the door when this equipment might be getting reconnected. So now we can have the power of the court to actually direct those people to cease any of those activities. Along with that, there's also adverse publicity notices where, again, Energy Safe Victoria can apply to the court, where the court will make a direction where those people have to have public notices printed in things such as newspapers and the like, stating that they have had action taken against them by Energy Safe Victoria. So again, we're hoping that these additional powers allow us to do our job more effectively, and that particularly being keeping the Victorian community safe when it comes to electricity. So thank you very much. My name's again Simon Elliott, with Senior Compliance Officer with the Electrical Installation Team. Thank you.